let's work on 4.1. This section we're moving into polygons as opposed to our triangles. We're going to start off with the sum of interior angles theorem. So this theorem is right up here. The sum will equal n, which is just your number of sides, minus 2 times 180. So what we're going to do here is you're going to be given a shape. Okay, so our first one is a pentagon. If you don't know how many sides are in a pentagon, you can look it up, or you can count it out if there is a picture given to you. But a pentagon has 5 sides. So that's going to be our n here. From that, we're going to plug it into our formula. So our sum will equal 5 minus 2 times 180. And then there we're going to simplify. So 5 minus 2 we know to be 3. And we're going to multiply 3 by 180, which gives us a grand total of 540, which is the sum of our interior angles of a regular pentagon, or just any pentagon actually. And we can do the same thing with a nonagon. Again, if you don't know something, like how many sides something has, feel free to Google it, look it up, but a nonagon has 9 sides. And if there's pictures, just count. So we're going to do sides will equal 9 minus 2 times 180. That's going to give us 7 times 180, which is 1,260. And last but not least, our 13agon. Normally after 12, you'll start to see this, or instead of calling it by a particular name, they just abbreviate it down. But still doesn't matter, it is still sum will equal the number of sides minus 2 times 180, which will give me 11 times 180, which is 1,980. The next thing is exterior angles. Exterior angles of a polygon for a regular polygon will be 360 divided by n. We'll say exterior angles. Okay? Super easy, super straightforward. You literally define your exterior angles of each of these. You just need to know your number of sides. So a triangle. Triangles have 3 sides. So our exterior angles are going to equal 360 divided by 3, which is 120. A heptagon is 7 sides. Again, if you don't know that, look it up. You can find lists of all your different side types. But our exterior angles are going to equal 360 divided by 7, which is 51.4. They're not always going to come out even. This one actually is a little irrational. Just round it to your nearest spot. Last but not least, exterior angle will equal 360 divided by 13, which gives me 30. Oh, sorry, that's 12. Typed in the wrong number. That is 27.7. Again, we have something with a lot of decimals, just round. Okay, so this now says, given the measure of each exterior angle, determine the number of sides. So this is what we just did, only now we know the exterior angles part and we don't know the n. So we'd set these up like this. Exterior angle is 30. Well, it's going to equal 360 over n, because we don't know n yet. Once you have this set up, what you can do is play a little switcheroo. So n will end up over here, and our 30 ends up on bottom of our 360. And so I get that n would be 12 here. Once you get used to that, I mean, you don't even have to write out the full thing, but it's always going to be the same. You take your exterior angle, equal it to 360 over n, and then you do your little switcheroo. So n's going to equal 360 divided by 18, which gives me 45. So this would be a 45-degree shape. And our last couple ones. Each exterior angle of a regular polygon is 45 degrees. What is the sum of the interior angles of our polygon? Alright, so we know exterior angles. Let's start there. Knowing the exterior angles, that's what we just did in 7 and 8. So 45 is going to equal 360 over n. We're going to pull our switcheroo. Oops. Sorry, I typed in wrong. This should have been 20 up here. But we're going to pull our switcheroo here. And 360, I'm sorry. N will equal whatever 360 divided by 45 is, and that ends up to be 8. Okay? So we have 8 here. The second part of my question says, what is the sum of interior angles? Well, that's our formula. Sum equals n minus 2 times 180. So now I'm going to do 8 minus 2 times 180, 6 times 180, and I'm going to get 1,080 out of it. It looks like this is a very similar setup here. So this is doing all of our work is the same. It's just multiple parts. So first thing is we're given the exterior angles. It's 21.18 equal to 360 over n. Well, let's do a switcheroo here. N will equal 360 divided by 21.18. 360 divided by 21.18. You're going to have to round to your nearest number here is what I'd recommend. It's going to make your life a lot easier. I got 16.99, and that's pretty close to 17. So it said approximately here, which means I'm going to round upward to that 17 so I can work with a whole number. Second part, we go to our sum is equal to n minus 2 times 180. And we get 17 minus 2 times 180. 15 times 180. And what would 15 times 180 give us? A very large number. 2,700. So that's our interior and exterior angles for polygons. If you have any questions, let me know.